Good morning, all. So today, this is part three of integrated Icehouses. I will upload the part one, part two soon. So in the integrated Icehouse architecture, we're going to discuss about Databricks and Snowflake, and I'll be working on similar architecture with Snowflake, Databricks, Cloudera, Snowflake, Databricks, Dremio. So all kind of combinations. Basically, any tool which can work with Iceberg, then we will be integrate. We should able to integrate. So I will be reviewing today Databricks and Snowflake and why this architecture became popular. But if you to understand more integrity, the like all the details and then how to set up and all the stuff, you have to go to part one, part two. But I will send you part one, part two, and mostly how to do the external volumes, how to connect the storage from Snowflake to S3 or Databricks to S3. I will walk through those steps, and then later you can practice that. Okay. So let's getting on. Sure, we have to give you credits. Okay. So based on my project experience, Databricks and Snowflake, we did a couple of projects, and then also most of the information coming from these Iceberg, Snowflake, Dremio, Tableau.io, Cloudera, Databricks, of course, AWS. So the presentation today, I'm using Databricks and Snowflake on AWS. You can do same thing in Azure or GCP, but more popular AWS and Azure on the Snowflake and Databricks combination. Then Cloudera, it can be any cloud, or Tableau.io or Dremio, it can be any cloud too. Okay. So today's agenda, then how to integrate Snowflake on Databricks Iceberg or tables we call as Icehouse, and I will explain what is Icehouse is. It's just a buzzword. Then we're going to discuss about how to set up a uniform Iceberg table in Databricks. The tables are Delta format, but we learn about Iceberg table format. But then more recently, Databricks also introduced a concept called uniform. That means when you store Delta table, you can also store same data in Iceberg format too. Then once you have data in Iceberg format, you can connect that Iceberg table from Snowflake using object store catalog integration. So what is object store catalog integration, and how to do that? We have to go back to the part one, part two of this integrated Icehouses videos. I will send it soon. Then how to do refresh whenever you upload new data in Databricks, how Snowflake can read it, then what are the strategies I will walk through and in this video today. Okay. So when we use Databricks today, most of the projects, right, we create delta tables. Delta table is kind of similar to Iceberg table, but of course they have their own metadata architecture. But the data is stored in a Parquet file, so the way the Snowflake does. So both Snowflake, Delta table store data in a Parquet format, and we learned about in previous Iceberg demos. Then, if you want to see that data, right, in Snowflake, generally what we do is we store same data into Snowflake. So from Databricks using JDBC, right, we insert into Snowflake table. But when we insert into Snowflake, more often we insert as a permanent table. Sometimes it depends on your use case, but transient table. Then Snowflake store the data in their own storage as a permanent table, right? We insert into permanent table, and this storage we will not be seeing it. For Databricks, of course, this is our storage. Our storage means your company storage, right? And then you can also read this delta table from Snowflake as external table, but it's very low performance. The performance is very bad. So generally, the architecture is if you have a Databricks and Snowflake, and you insert data into Snowflake, and then then what is the issue here? So when you insert data into the Snowflake, you have to use Databricks compute engine. Of course, you already stored as a delta table. Then you need a compute engine. Then to store in Snowflake, you need a compute engine. Then while you are storing into Snowflake, you need a Snowflake compute engine. So double compute. So it's extra cost. Then you are also storing same data in Snowflake storage, double storage. So here, double compute, double storage. So what new I mean, again, we have been doing this one. I did in a couple of projects like this. And then in the new architecture, what we did, and even the Databricks and Cloudera, Snowflake guys are promoting in Cloudera, Dremio, all other tools also companies also promoting. So the new concept is, um, so we're going to store instead of a delta format, and we're going to store as a uniform format from Databricks. So Databricks is going to store as if they are storing a delta table with a small one-line change, and then we're going to store in the uniform. So I will explain what is a uniform. Then Snowflake can read that Iceberg table directly using object catalog. So now here you are storing only one time, one compute, and one storage, common storage for both Databricks and Snowflake can read whenever they want it. So here, no insert compute. Previously here, we need a compute for insert. Of course, when you are selecting, you need a compute, but you are avoiding that compute. So now you are a cost saving. So if you are inserting continuously a lot of data and billions and many tables, is very expensive just to store. Then of course query you have to pay for it anyhow. But here we are avoiding double computing. So here we don't have to insert here, and then there's no compute here, and then you are reading whenever you want. So this is basically a drastic change in the compute world. Next is common storage, right? Now here, I can bring another engine, right? I can bring Databricks, I can bring Dremio, I can bring your own Spark, right? any other tool, Trino or any other tool, or big table from Google Cloud, right? You can read that Parquet file and Iceberg, because Iceberg is a universal table format. So now many companies are moving towards. And then another advantage here is right now we are in AWS, right? If you don't like AWS, you can just move Parquet files to your GCP or Azure, then you're done, right? So you don't have to change any file format because it's a common Parquet format. So this is how the new architecture, single storage, many computes, and common file format. So anybody, so here, of course, definitely only one tool is reading and writing it, but any other tools can read anytime they want. So this is where you save a lot of cost, and then you're not losing your performance, and still you maintain your security RBAC here, your RBAC here, and then nobody can see these files. That kind of architecture you can build. So drastic cost saving model we implemented in many projects. Then of course the whenever we Databricks writes into a uniform table, we need to tell Snowflake, okay, we completed writing into uniform, because this is read only, and Snowflake should aware, okay, we completed. So it's a single very tiny call, just an alter table refresh, and then it doesn't take not even a fraction of a second to make a call. And then so again, you're reducing the cost of your total ownership. Okay. Now similarly, right, Tabular can do that same thing, right? Instead of Databricks, right, I can replace Databricks with Tabular, and Tableau writes Iceberg table. Again, now keep in mind, when you are dealing with Iceberg table, whether in a Snowflake, whether in Databricks, whether in Cloudera, whether you're doing Apache Iceberg, all syntax are similar. Small changes here and there, but once you learn Iceberg, you can implement any of these tools in the Iceberg technology. And same thing here. So let's say, for example, I am showing here a tabular. Tabular can write Iceberg table, Databricks can read it, or um, sorry, Snowflake can read it. Even Databricks also can read it. Okay. Um, Give me 1 second. Somebody is waiting for. Yeah, I will come back. Questions. Okay. So what is the ice house? Ice house is nothing but is a buzzword now, right? Your Iceberg table, of course, your storage, then any SQL which can manipulate, modify DDL, DML on Iceberg table or Spark. So Spark engine or SQL engine, then Iceberg table format we call Icehouse. Now this is Icehouse. Tabular, Iceberg is Icehouse. Snowflake, Iceberg is Icehouse. And Databricks uniform table is Icehouse. So then we are attaching these Icehouses, and now they're called integrated Icehouses, attached houses, and some kind of way of expressing a uniform table, Iceberg table with an engine. Right? Engine can be a snow. So if you are familiar with Snowflake, Snowflake SQL can work. If you are familiar with Databricks Spark, Databricks Spark can work on it too. So if you look at here, before and after, right? The Databricks REST Delta table, and you insert into Snowflake, and then it will become your permanent table. Then instead of that, you can convert into. So we can simply convert Delta into uniform with alter, or any feature table you can store as a um, um, the uniform table. Then you integrate that uniform table with the S3 object integration, and then Snowflake can read this table as it. So you have a customer table here, you have exactly same customer table here, right? So you can query customer table and you can insert update. Now this is a solid line because it's doing insert update, and this is dotted line. Snowflake can read all of the latest data. Then after that, you can share this data to other databases, or you can implement share, you can implement whatever you want to do, or your dashboards, everything in this architecture. Um, so common way of doing most of the projects we have implemented, right? So we get raw data, we call as branch, right? Then you do some, transformations, right? You can call it silver data. Then after that you convert, then you will have a final gold data. That means your type 2 tables, or any other fact tables, transformation, whatever, if you connect to other sources. Then once you have gold data, previously what we do, as I said, right, we're going to store in Snowflake, but now we can simply, Iceberg is connecting. So of course, Snowflake also can connect silver, bronze, but we don't want it. We want the only final data. And so all your rules engine, all your transform ELT, ETL, whatever you call, and if you have a rules engine, everything is done through Spark or in the Databricks. And again, more often we use PySpark and Spark SQL. Then once you store your gold data, you may call a refresh. Now anyone querying from Snowflake, they will see most recent data here. So now again, common storage format. Now any other, then Tabular can come and read this one, not a problem. So this is, I have implemented, my team and others previously implemented the similar architecture. We saw a lot of cost reduction in Snowflake, particularly because, of course, some cost reduction database, because every time when we want to insert multi-billion rows here, we have to do refresh. Then updates, we had a tough time. But now with this, you have most recent data available in this Iceberg architecture. So I will give a quick pause. Questions?
Okay. Yeah, that's Sridhar, Satya. So, are these, will they look like external tables in Snowflake, or?
No, it's an Iceberg table, right? Snowflake now introduced a concept called Iceberg, right?
Oh, okay.
Yeah. So now Snowflake manages if you go to, I will send you the part 1, part 2. In Snowflake, now for us, looks like an external table, but as the end user, it's a table, of course. But this is an Iceberg table. So the performance is almost equal to a permanent table. right?
Oh, okay. So
Yeah.
they
So
do micro partitioning and all that.
yeah,
Okay. Yeah.
the no, it uses the Iceberg metadata, right? So no
Oh,
more whatever you have Iceberg table here, then Snowflake uses. Snowflake doesn't do anything other than querying Iceberg metadata. So your Iceberg table is almost equivalent to the Snowflake micro partition, right?
I
It
see.
does hidden partitions and everything. So Snowflake engine does only simple okay goes. They also have a similar Apache jar file, of course, right? And then they read the Iceberg table. So whatever architecture you implemented through Databricks, whatever the partitions and then your schema, everything is universal here. The Snowflake is reading it, and performance is on par with the permanent table. So that's the reason we are supporting this. If it is a external table, no, right? Why bother? It's very slow.
Yeah, got it. Thank you. Yeah, that's good. Looks like Snowflake reads that metadata, understands that Iceberg metadata now, and then it'll convert into its own metadata, maybe.
Yeah, no, it has two formats. One is a Snowflake catalog. That means it's now what is a Snowflake catalog means you can create an Iceberg table from Snowflake, store here, and then Snowflake manages the read write. But this is a Iceberg the object catalog. That means it does only read only, and this guy does all the update insert. Databricks does the update insert management, but Snowflake
Oh,
just read it. Yeah.
okay.
So if you create an Iceberg table from Snowflake, then yes, you can do insert update deletes directly from Snowflake.
Oh, okay. All
Yeah,
right.
so it had two formats. One
Mhm.
is Snowflake catalog. That means Snowflake knows the snapshot information. So the reason here, Databricks knows the snapshot. Okay, what is my recent metadata JSON? What is my recent schema and all the stuff? Because Databricks manages the catalog. But here, when you are reading the object integration, but the Snowflake doesn't maintain it does not maintain the catalog. But if you create Iceberg table from Snowflake, yeah, then Snowflake engine has a catalog. Okay.
Okay. So
Yeah.
the owner maintains the catalog, and yeah, it keeps it.
Yeah.
Whether it's Databricks or Snowflake, whoever creates the object. Okay.
Yeah. Yeah.
Got it.
So yeah, then so there are some if you go back to part one, part two use cases, those are mostly focused on how Snowflake is creating Iceberg tables and how to do and all the stuff. Then I seen one project. I gave the architecture. We converted entire Snowflake permanent tables into Iceberg table. So we moved away. So basically here, going back, what we did is this is Snowflake, and we converted everything into Iceberg tables. So that's the part two. I'll send the video later. Yeah. Okay.
Great. Thanks.
Yeah.
Such a quick question on
Go ahead.
you had that table refresh from Iceberg table metadata refresh from Databricks to Snowflake, right? What refreshes metadata refresh will be done for catalog for the Snowflake as well?
Yeah, I will show that. Yeah. Right. Yeah. We'll come back to. Okay. Okay, so what is the workflow? You have a Databricks, right? And you create an Iceberg delta table in a uniform table format, right? So any table you create. So now, common question is, oh yeah, I've been creating delta table. Now, if I change to uniform table, will that have a performance impact? Will that have a storage impact? Will that have a catalog cost impact? No, this is a tiny metadata. At least I didn't see it. Maybe in a bigger scale, you may see some uh, performance, but you're writing very tiny metadata. There is no storage. You're not writing massive storage because it's metadata only, and then we don't see any much cost difference. Of course, Databricks engine handles read-write operations because Databricks owns the Iceberg table catalog. Of course, underneath Databricks, they use Hive to manage the table information. But of course, they use, and also on top of that, they use Unity catalog. So you have to have a Unity catalog to implement the Iceberg uniform table. In the feature class, I will walk through Databricks Unity catalog and how to set up, and then I will give you the overview of the Databricks. Then in the Snowflake, we call object catalog integration. Remember the word object, right? So there is a Snowflake catalog, object catalog. What does that mean is a Snowflake has its own catalog, or Snowflake can read from AWS, or Snowflake can read from Glue, or in the future they can read from Hive, EMR Hive, or you can read from other catalogs. So catalog is nothing but a database where it maintains your Iceberg version. That's about it, right? Where is the location of the Iceberg table? What is the version? What is basically, which is nothing but what is the most recent snapshot? So we'll dive in the upcoming Iceberg classes. So Snowflake object catalog integration access Iceberg tables from object store, which is S3. It can be also mini IO in read-only manner created by Databricks uniform table. So that's what important here. So in read-only manner created by Databricks uniform table. Okay, and so Databricks. Let's get into very quick. So I create a table in Databricks. If we don't define this, delta dot universal format dot enable formats Iceberg, you can just create a table, standard using delta. Then it creates a delta table, which is another format of and is proprietary of mostly proprietary of Databricks. But now, last summer, actually late last summer, they introduced, okay, you can not only store as a delta table, you can also store additional metadata, which is in Iceberg format. I will show that one. So when you create this table, automatically it creates a Parquet file because you need our data. Then it also creates delta metadata and also Iceberg metadata. Okay, let's get into that, how we see it in Databricks. Okay, so when let's go to Databricks first. This is my Databricks workspace. Okay, and I have two workspaces, Ambari AI, Iceberg. Workspace is basically in our organization. You have a Databricks account. You have a Iceberg. You have multiple projects. Think that way, workspaces, right? Project one may be connecting to one bucket. Project two connect to another bucket. Then project one has different rules and different use cases. Depends on whatever. So right now I'm using free trial, but still using uniform format. Now, when I create a table, okay, let's go to here. So simple SQL, right? Databricks now provides the SQL notebook. You don't have to do a lot of, if you are doing a lot of SQL, yeah, you can directly do standard answer SQL. But of course, when you do rules engine based, all other, then yeah, you have to use the PySpark. Then yeah, you can change, what model you want. You want in a Databricks PySpark model, you want a Scala, you want a SQL. So here I just created a table, right? While I'm creating the table, right, I don't have to define saying that delta because it's already delta format. That is default. Then saying that, okay, I'm going to create a table, right? And then, so when I create this table here, Databricks maintained it has its own catalog. Right? Catalog is nothing but a database, maintains your table name, column name, location of the table, and column data types and all this stuff. That's what the catalog is. It's a data about data, right? And then once you create the table, I insert some data, right? And then show me the table properties, and then if you look at here, I know it is showing as an Iceberg format. If I don't do that here, right, then you won't see Iceberg format as a table, Iceberg format, right? And so basically simple syntax. You don't have to add extra anything. I mean, there are other table formats which related to delta. Yeah, you can add those. And once you create a table, and then when I do Databricks configuration, and then this table data is stored in my AWS account. Okay, so I logged into AWS. This is the ambaricloud.com AWS. So my company AWS. and Databricks storing in my AWS storage. Of course, if you look at here, I didn't go, this is my bucket name. I use the Databricks bucket name. So now if you go to here, tables, I have, different tables. Then, click on the table. Now, when I create a table, look at this delta log. This is for delta table. So whenever you create a table through Databricks in a delta, of course, a standard delta format, then it maintains its own metadata. So it talks about what is the table name, what is the version, what is the schema changes, and everything, all the entire history or insert updates. Then going back, and my data. So if you look at here, my data is stored in Parquet format. Right? So this is a standard happening. Now, since I requested the table insert as also uniform format, now then it's going to create a metadata directory. This metadata directory belongs to Iceberg. So when you click on here, and I'm sure people who are already went through Iceberg class, you will see meta.json, and it maintains the version. Then you will see snapshot. Okay, what is my snapshot? Most recent snapshot. Then where is my file, Avro file. So this is a metadata list and metadata file location, right? So basically manifest list, manifest file, right? Manifest file location. So now look at this. This is very tiny, right? It's not occupying much space, right? And then of course you can do in your through Databricks, you do your vacuum, your compaction, your cleanup, and your time travel. All those things you can do through Databricks. But coming back here, when you create a table, this is delta log table, which is for delta, and this is our data. Of course, you have to have data files. Then since it's in uniform format, it's going to create a metadata directory. This is how. Now, when you read through Databricks, Databricks uses delta log. Why are we creating this metadata directory? Because we want to read the same table, right? I want to read the same table, customer 21 table from Snowflake, right? Previously, right? Which is already created on my AWS storage. And Snowflake, what we do is we will create a table in Snowflake with object integration. The Snowflake connects to this metadata and finds the most recent metadata JSON. Then after that, then it uses the Snowflake. It uses Iceberg, Apache Iceberg, the software. Then it reads the Iceberg table, but within the Snowflake, right? So questions on the Databricks side. So Databricks, again, they are Snowflake and Databricks are, fierce competitors. But our companies use in a different ways. Anyhow. Okay. So now let's get into our, so standard, as I said, standard table, delta table, and then we have insert. Then, make sure that this, you need to define your format. Then, so when you then every time when you insert, right, then it will tell you where is the actual location of your table, right? If you look at here, again, I'm not customize the names here. You can actually generally customize it, and then it says your company bucket name, then in the actual table name. I removed all those for easiness. But yeah, when you in our companies, yeah, you don't use Databricks workspace. You use Ambari Cloud, Satya, Ambari Cloud, your XYZ company, right? And when you describe extended, yeah, you will see your location of the table, all the information. Now this is a managed table. And of course, you can do the external tables and all that stuff. And then, as I said, right, when you see what is the table properties, this is okay. Yes, we enabled Iceberg. That means, of course, you can disable later if you don't want Iceberg. If there's so in the companies, what's happening is you have a Databricks team sitting somewhere. You have a Snowflake team, in a different department, and but Snowflake guys want you read the Databricks data. So historically, you have to talk to the Databricks guys, then ask them to insert into Snowflake. Now all you need to do is change the architecture, the enterprise level, instead of inserting into Snowflake, convert them into Iceberg table. Then once we have Iceberg table, then Snowflake guys can read without even talking to Databricks guys. That's how the architecture is going towards. Then reduce the storage. As I said, okay, you have a delta log table where which maintains the delta metadata. The LIZ is basically directory structure. Yeah, you can. There are, you can rename all these things when you do the table formats. I don't want to dive into that one. We will dive later in a Databricks class. These are the metadata for Iceberg for uniform table. Okay, and of course this is the delta metadata. Then in delta files. Okay, so on the Snowflake, what is the first thing we need to do in the Snowflake? A Snowflake, now if you go back to our architecture, you have a storage. Snowflake is an engine. Then Snowflake has its own storage. But now you want to connect your storage to your Snowflake account. That means you have to do a handshake. So for that, what we do is we will create an external volume. So an external volume is an object connecting between your Snowflake to your S3 bucket. Okay, so you basically your Snowflake account to your S3 bucket, your S3 account, because those are separate. Because this is a separate account, this is a separate account. That means you need to integrate. For that, we use a external volume. So what we do is we create an external volume. It's an object. It's like a it's like another table structure. It's kind of a mount point. Then you create that one. Then you make a you connect to your S3 bucket. Okay. So what we do is, the first thing is you go to AWS, you create a policy that means who can access this S3 bucket, right? And then what are the roles? Read role, whatever. So there is a requirements when you want to do Iceberg table. Snowflake provides that what kind of action IAM policy, IAM roles. Basically, it's a role, right? And then what we do is we create an external volume in Snowflake. Then we integrate your AWS role with an external volume. So using ARN. So whenever you create a role, the AWS creates a ARN number. Then you need to tell to your Snowflake, okay, there is a S3 bucket, and then I have a role, and you can, so you connect that S3 bucket through this role. Then basically it's now basically Snowflake is saying that, okay, I can talk to you. Then what we need to do is, but of course we have to complete the handshake, right? So the Snowflake saying that, okay, I know what is the S3 bucket, what is your number, but I'm going to create some ID internally. Then they do a handshake. So this is a multi-step process. This is common when you are working on Snowflake, whenever you want to connect to an external storage, and this is nothing to do with Databricks and other thing. If you want to create an external tables or Iceberg table, you have to do these steps. I went through step by step in the part one. I will update anyhow. Okay, so this is how you are connected to S3 bucket. So this is AWS account. This is a Snowflake account. Then you make a connection between your role. Of course, this role belongs to you. You cannot connect to a bucket without a role, because this role is telling you have access to this bucket. Because otherwise, anybody can access to this bucket, and then they can update, delete data directly from the disk. So we are not giving disk access to any users, but the users in the Snowflake can access to this disk via table only. That's why this is using it via an external volume. Okay, that's what we designed that. So remember, this is a initial step, but mostly done by the AWS DevOps guys and also Snowflake admins, right? Okay, so we're going to create a object store catalog. So here object store is S3, right? And then what is the object store catalog? For that, we have to go to multi-step. What we need to do is we need to create a some object called catalog integration. So it's for your entire Snowflake account, you will have a one object store. That means I'm going to connect to, I have an object store. Remember, we haven't defined the object store, which can be S3, ADLS, Azure, or Google Cloud. Then we create an object store integration. Then we give it to the individual roles. So everything in Snowflake, you work through roles. We don't give it to individual users. Always that's a same thing in the database. No individual users. Why? The individual user may gone after some time, right? So everything has to go through roles only. So what we do is we will give access to this object integration object to a role, which is we already created previously. And then, so in a given database, right? And of course, given schema, of course, the user, what they will do is they create a table, what is called Iceberg table. So in Snowflake, we will create a table, which is a permanent table, or we create a temporary table, is called temporary table in our session, or you can create a transient table, which has only time travel of 1 day, right? Permanent table, whatever the define of the time travel. Then you are creating this table, right? So look at some table name, but we call as Iceberg table. We have to, it is very important. Then we are connecting to your AWS S3, okay? Your S3 through this external volume. This is basically your main point. Then of course, what is the catalog? Now here, the catalog can, remember we created a catalog name called object store, but there are catalog kind of like a glue. You can connect to glue, which is owned by EMR, or Snowflake has its own catalog. It's called Snowflake catalog. So in part 1, I will be discussing about Snowflake catalog and also about this object catalog. In the future, I'm going to walk through glue catalog. Then we are telling to this table, okay, this is my S3 bucket. Of course, I'm going to use object integration. Then what is my most recent metadata JSON file, which is very important because I want to read most recent data. This metadata JSON, as we learned through in Iceberg, maintains the time travel, maintains the time travel. So every time when you update or insert or delete some data in Iceberg table via Databricks, this file changes. This file changes. So that means we right now I created this table, right? Whatever the data. But tomorrow, if I, let's say after 1 hour, I insert some data, I need to change. That means I need to alter this table with the most recent file. If I don't alter with most recent file, I will be seeing the previous day data or previous transaction data. So that is what called refresh. Remember I mentioned that from Databricks, whenever we update the Iceberg table, we need to refresh this table. So what do you mean refresh means? We need to get the most recent file from the disk and alter and this table. And then that takes, in a fraction of a second. Then once we're done, then you can query this table. So from Snowflake, as if you're as if it is a Snowflake table, but actually this is an Iceberg table. The whole data is sitting on your disk, which is created through a database. So when you query, the data here is exactly same as what data you have in your Delta table in uniform format. Okay, let's go through quickly and right. Okay, look at here. This is my my Snowflake. So I will walk through slowly. When you're practicing, pause this video and then look at the code and type it and practice it. That's why you will be learning better rather than just to cut and paste and practicing it. So here, as an admin, right, I created a external volume. So when you create an external volume, so you give some name and what is my storage provider, and then what is my bucket name. Remember I mentioned that when you create a role, this is my role. So using this role, I'm connecting to this bucket or this directory, right? Right. So basically I'm telling my Snowflake, I'm going to connect this bucket using this role. But again, So Snowflake is telling to the Snowflake has this information about bucket and role, but what about AWS? AWS doesn't know yet about your Snowflake. So what we do is once you create an external volume, you describe it. Then there is an external ID. Then there is a user. So you give this information to AWS, saying that okay, I'm Snowflake, and I'm using your role, and I want to connect to this bucket. Then knock knock. Then the AWS says, okay, who are you? I'm the AWS IAM user, and this is my ID. So this information, you go to um, AWS, you set that one. Okay, let's go to the AWS quickly. Where is my AWS? Now, if you go to IAM roles, right, and then if you go to roles here, and then if you do SF role, right, and then if you click on okay, so then trusted relation, look at this one, right? So whenever Snowflake has, right, Snowflake has your ARN number, this is ARN number, and Snowflake has a bucket name. Then AWS has Snowflake user ID and external ID. So now that's how the handshake happening between your Snowflake to AWS. Once a handshake happening, Snowflake can insert, update, delete in the bucket or whatever required based on this role and assume role. So that's how we set up in the. Once you have that, then you create an object store. Then you give access to your role. Then you create a table. Now you give a path to most recent metadata JSON. Okay. Now you create a table. Then when you query, let's go to query here. I'm going to query. Okay. Now look at this one. I have the data Bob1, Bob2, Bob3. Then when you go to Databricks here, and then I insert Bob1, Bob2, Bob3 here, right? So Bob1, Bob2, Bob3, and then so if I insert new data, right, you will not be seeing that data in Snowflake immediately, right? What you have to do is you need to do a refresh. So from Databricks, what we do is we know from Databricks the most recent JSON file. Then we run this statement, just alter. Or you can have your a task or maybe some Python cron job or whatever, whichever way. Mostly you can create a task. Then the task will run. Let's say you are doing a batch job in hourly, then you can run a task hourly here. Depends on your use case, right? If you want your data available immediately, as soon as the Snowflake insert updates are done, okay, and how soon you want this data available to the user, right? So let's say this is a nightly batch. Then you don't have to call a metadata refresh from Databricks. You can have a task. Or as soon as you insert, you want that data is available through Snowflake. Yeah, then run simple refresh, which is but a alter table. Give me one alter table. Then you just alter the table and give me 1 second here. You execute and get them alter table. Okay, what is the question? Good. So how do you do alter tables, right? From Snowflake, from Databricks, right? So Databricks allows to JDBC connector, right? And you have a connect, then you can create a simple store procedure in Snowflake. Then you call that store procedure. Then from Databricks, of course, you can generalize this procedure. Is give a table name. Then you can pass the most recent metadata JSON, or Snowflake can connect to your bucket since it has already have access. Using the state, you can get the most recent metadata JSON file, and you can get the value and then alter this. as this alter takes in a fraction of a second, immediately now you will be receiving most. Let's say right now this is 02. Then if you are most next file is 03, then you will get the most recent JSON data. So yeah, if you look at right how again, let's say how to get most recent JSON file from a my AWS bucket. Ask ChatGPT, it will write code for you. So yesterday, ask ChatGPT, give me most recent metadata JSON my HDFS file, HDFS file system. It write a Python code for me. So you can ask same thing, how to get most recent metadata JSON file in a S3 bucket through Snowflake. So it will write try it through ChatGPT, right? It will write the code for it. So if you look at here, yeah, a simple alter, right? Now let's run this alter command. Now I don't have that file 03. Now let's go back to 02 file, right? Now I'm going to run. Okay, successful. That means now my table, right, connects to the most recent metadata JSON file, whatever insert updates are done, and then I can then simply select star from customer, whatever the table name is, then my data. So I did a performance test on this table, and I loaded 5 billion rows from Databricks. I loaded 5 billion rows. Then I ran the query from Snowflake. Then what I also did is I loaded another 5 billion as a permanent table in Snowflake. So I compared a Snowflake permanent table, and then let's go back here. So yeah, so I compared the same table directly as a permanent table, 5 billion. Then I have a 5 billion here as a catalog Iceberg table. I see the performance is same. Maybe when you go to 100 billion, 200 billion level of data, you may see maybe a little bit different. But at least my tests are within 5 billion. Next is I want to test for a 50 billion table. In a grand scale, you don't see much performance impact. But if it is external table, yes, it is very slow. Okay. Give me one further continues. So yeah, this is how you want to refresh. You want to refresh from Databricks, then you need a JDBC connection. The way you insert tables data in Snowflake, or you can have a Snowflake refresh by itself whenever on a time basis. You can have some kind of a task running every minute, or depends on how often you do updates, deletes, inserts on the Iceberg uniform table from Databricks. Okay. Then yeah, this is how you do a connection string. Then basically what is ready, your warehouse and all the stuff. Then you simply call, automatically you are making connection from Databricks. Okay. Then you can also you can also pass the most recent metadata JSON, because every time when you insert, update, delete a uniform table, Databricks maintains the metadata location. So every time when you insert, update, delete, then simply describe the table, you will get the metadata location. Once you have the metadata location, then you simply call alter Iceberg table customer refresh from your JDBC call. So look at here, simple code. You're executing this text. It's not even 2-3 seconds. Depends on all the connections we have. So this is how I have implemented. And then okay. Yeah, we saw the demo here. So this is my workspace. Then when I insert, I haven't started the cluster yet. Let's go to the compute, and this is my compute. Then I'm using Unity catalog, and then when I start this one, then it will start 6 nodes in my AWS account. Once the nodes are done, then I will go to my notebook. Then I will do simple insert. As soon as insert done, it's going to create a new metadata JSON file. Then after that, I will get the latest metadata JSON, then refresh from, execute the refresh, then I can execute from the Snowflake. So now if you look at architecture is one storage and multi-engine. That means now each engine connecting to Iceberg, we call Icehouse, which is a Iceberg table, storage, and your engine. Then you are connecting to other engine can also connect and execute the data. So that's how the architecture here. Okay, so in the future, I'll be planning on doing more architecture hands-on on Iceberg table again, and I'm planning on doing DuckDB. Of course, we'll be planning on doing some LLM long chains and all the stuff. So that's how the architecture we will be looking at. Questions? And it's being implemented in a lot of places. Nothing new, right? We're already starting. It's on production. Then now, if you look at Databricks is also promoting uniform table through Unity Catalog, and same thing. Snowflake, their blogs also writing a lot about Snowflake Catalog and Iceberg Snowflake Object Catalog. Then of course Cloudera is begun open Lakehouse, Dreamio, then the Tabular.io, which is Ryan Blue. Those guys are implemented the original inventors. So the goal of this architecture is common storage, right? Reduce the stickiness, right? Then you can move to any cloud, you can move to any tool, and then you can migrate from one tool to other tool very easily, right? So that migration, there are two parts of migration I will be discussing. One is Snowflake to Iceberg migration, so no more permanent tables, right? And then or Snowflake to some Cloudera, how to migrate from Snowflake to Cloudera or Cloudera to Snowflake. Those are the architectures I will be. So the migration strategies, right? Databricks to Snowflake. Okay, you want to move away from Databricks to Snowflake, or you want to move away from Snowflake to Databricks or Cloudera. All right. So whatever tool you want to eliminate, but if you're in Iceberg format, the migration is very easy. So that's architecture I will be discussing in part 4. Yeah. Questions? Okay, good. Yeah, definitely look after this architecture. Companies start implementing it because easy to implement, right? And you don't see performance hits. Then of course a lot of people also migrating some code into using DuckDB. Then now the goal is row ice houses. That means you can have many engines can act on it on a common storage. Let's say you have a department, we already been working on Databricks, another department already working on Snowflake, but they want to exchange data, they need other tool data, other storage data. Now you can convert you into one common storage. You don't have to have a Snowflake storage, Databricks storage, Cloudera storage, or a common storage. One storage, one format. Anybody can read, and then easy to. Then you don't have to write stored procedures in Snowflake. You can use standard SQL, or maybe Spark. Spark is becoming a Spark SQL. And reduce the cost, and then common, and then your engineers also in the same level, right? Everybody learning Iceberg, and then everybody can talk same language. That's how it's moving towards. Okay, and if you don't have any questions, and then I will send you this video later, and we'll talk to you guys. Thank you all. Have a nice weekend.
Thank you. Bye.
Sir.